Today we will discuss about feedback amplifier. Let's see the introduction about the feedback. Feedback is used in virtually all amplifiers. Why we use this feedback in the sense? In order to reduce the gain, at the same time the bandwidth can be increased. In a feedback system, a signal that is proportional to the output is fed back to the input and combined with the input signal to produce a desired system response. And this may be in proportional to the input or may not be proportional to the input. That is, it may be 180 degree phase shifted or it may be in phase with your input. And however, unintentional and undesired system response may be produced with the help of this feedback. And it is the method to stabilize the gain of the amplifier for use in telephone repeaters. Feedback amplifier. Feedback is a technique where a proportion of the output of a system is fed back and recombined with the input. So here we have the input and the input is given directly to the amplifier and we can take the amplified output across the output terminal. Suppose if we have a feedback, then we will have a feedback and that factor will be denoted by a term called as beta. And this beta is nothing but a part of your output which is obtained from the output terminal is fed back to the input. And this beta may be added along with the input or it may not be added along with the input. Otherwise, it can be subtracted. So that is why here we have two types of feedback. One is called as positive feedback and the other one is called as negative feedback. The positive feedback is a process when the output is added to the input and amplified again, and this process will continue. That is, for example, if we have a mic and we have a speaker, the output which is obtained from the speaker is once again given to the mic, then that type of feedback is called as positive feedback. So the gain will increase further and it will have an unpleasant effect. This part is called as positive feedback, and this feedback is mainly used for oscillator. This is used to generate an oscillation with the help of this positive feedback. And the second one is negative feedback. Negative feedback is when the output is subtracted from the input, then that is called as negative feedback. That is, your input and the output will be 180 degree phase shifted, or the input is subtracted by the feedback factor. That is called as negative feedback. The use of negative feedback reduces the gain, but part of the output signal is taken back to the input with negative sign. For example, in speed control, if the car starts to speed up above the desired set point speed, then the negative feedback causes the throttle to close, thereby reducing the speed. At the same time, similarly, if the car is very slow, the negative feedback acts to open the throttle in order to increase the speed of the car. So likewise, we can increase the ability of the amplifier with the help of this negative feedback. When we go with positive feedback, this is not possible because the transistor will go to saturation and it breaks into oscillation and it will give you a continuous output. The advantages of negative feedback are gain sensitivity. That is, variation in gain is reduced with the help of negative feedback, and bandwidth can be extended to a larger extent. If you don't have feedback, then the bandwidth is very, very small, and if you have a feedback, then the bandwidth can be increased further. And it is noise sensitivity. Increase the signal to noise ratio. And the next one is reduction of nonlinear distortion. Nonlinear distortions can be reduced, and it is used to control the impedances level. I can either increase the impedance in the input side or in the output side, or I can decrease the impedance on the input side and the output side. So accordingly, with the help of this impedance levels, I can increase the gain or can decrease the gain. And feedback is used to make the operating point of the transistor insensitive to both manufacturing variations in as well as temperature. That is, usually the transistor depends on the main parameter, temperature. Whenever there is any change in the temperature, then the operating point will vary. If the operating point varies, at the same time, the gain of the amplifier will also vary. And it is common in the case of manufacturing variations also. So that is why if you give negative feedback, this type of drawbacks can be overcome with the help of this negative feedback. And the major drawback which we face here in the negative feedback is the circuit gain. The gain decreases when we give negative feedback because the overall amplifier gain is reduced compared to that of the basic amplifier because of the negative feedback which is given to the amplifier. and it affects the stability too, but the stability must be taken into care, since if the stability is not maintained, then the amplifier breaks into oscillation and it becomes an oscillator. So these are the major two drawbacks which we face here in the negative feedback. And now we'll see what is a feedback amplifier concept. In the feedback amplifier, actually we have 6 different blocks. The first one is the input signal, the second one is the output signal, the third one is the sampling network, and the fourth one is comparison or the summing network, fifth one is basic amplifier, sixth one is feedback network. So all these things are comprised together, forms a feedback amplifier. The input signal, comparator, basic amplifier and sampling network forms the basic amplifier network along with the feedback network. A part of the output is sampled in the output side, and that is taken as a feedback from the output, and that is added or subtracted in the input side. If it is subtracted, then we call it as negative feedback, and if it is added, then we call it as positive feedback. So with the help of the structure, we can simply say that the source, let us assume that the source to be SI and the feedback to be SFB. Here in this diagram, we have applied a negative feedback so that the input will be subtracted by the feedback which we obtained from the output. So the error signal SE will be obtained, and that is given as an input to the amplifier, and we have to take the output in terms of S0, and that is given to the load. The basic concept has got the output signal is S0 is equal to A into SE, because here SE is nothing but the input and S0 is nothing but the output, and A denotes it is the gain of the amplifier. So the gain is equal to output divided by input, gives you the output is equal to gain into the input signal SE, because SE is nothing but the input which we have given to the amplifier, and where A is the amplification factor. Feedback signal is SFB, that is equal to beta into S0, because in the feedback part the SFB is nothing but the output which we get it from the feedback, and S0 is nothing but the input which we have given to the feedback. So the gain of this circuit is beta is equal to SFB by S0, where beta is nothing but the feedback transfer function. At the summing node, the error difference between the two feedback and the input will be found out, and that will be taken as the error signal amplifier, and that is given as the input to the amplifier. The closed loop transfer function or the gain is thus given by AF is equal to S0 by SI, where S0 is nothing but the actual output which we get it from the amplifier, and SI is nothing but the actual input which is given to the circuit, and that is equal to A by 1 plus beta AB. And if beta A is more than 1, then the gain will be equal to A by beta A, that is equal to 1 by beta, which is nothing but the feedback factor. And now we will calculate how this entire thing will be done. And here the input signal SI and the output signal S0 and the feedback signal SFP and the different signal SE, each represents either the voltage or the current. Because we can able to construct a voltage amplifier, at the same time we can able to construct a current amplifier. Both are possible. So if we want to construct a voltage amplifier, then everything will be in terms of voltage. If I want to take this in terms of current, then everything will be in terms of current. So here assume that this error signal may be a voltage or it will be a current. According to the voltage amplifier, if it is a voltage amplifier, we have to take this as voltage. If it is a current amplifier, then we have to take it as a voltage amplifier. So with the help of this, we can able to generate the corresponding sequences, and finally the gain A is equal to A by 1 plus beta AB, and this denotes that the feedback amplifier